Now let us understand potential hydrogen, or pH, and how it affects the hair, skin, and nails. Our learning objective for this lesson is to explain what pH is and how the pH scale works. Notice that pH is written with a lowercase p and a capital H. The P represents the potential of, or quantity of. The H represents the hydrogen ion. Therefore, the symbol or abbreviation pH indicates the potential of, or the quantity of, hydrogen ions. Before you can understand pH, you need to learn about ions. An ion is an atom or molecule that carries either a positive or a negative electrical charge. Ionization is the separation of an atom into positive and negative ions. Anions are ions with a negative charge. Cations are ions with a positive charge. In the example of water, the molecules ionize into anions and cations. The pH scale measures these anions and cations. Cations with a positive charge are acidic, whereas anions with negative charges are alkaline. When we separate a water molecule into ions, we get one positive hydrogen ion. This hydrogen ion carries a positive charge and is our cation. The cations are those ions with a positive charge. In the case of water molecules, this is the positive hydrogen ion. The hydrogen cation is acidic. Then we also have an anion, or one hydroxide ion, created from the oxygen and hydrogen combination that carries a negative charge. This is because oxygen will not carry an electrical charge by itself, and must be attached to another molecule to carry a charge. In the case of water molecules, this is the negative hydroxide ion. The anions are those ions with a negative charge. The negative hydroxide ion is alkaline. The more positive hydrogen ions a substance contains, the more acidic the substance is. The reverse is also true, wherein, the more negative hydroxide ions a substance has, the more alkaline it is. Pure, distilled water is neutral because it contains the same number of hydrogen ions as hydroxide ions. It is an equal balance of acid and alkaline. As acidity increases, alkalinity decreases, and vice versa. As alkalinity increases, acidity decreases. A pH scale is a measure of the acidity and alkalinity of a substance. It has a range of 0 to 14. A pH of 7 is neutral, meaning it is neither acidic nor alkaline. The pH of a substance that ranges 0 to 6.9 indicates an acidic solution. The pH of a substance ranging from 7.1 to 14 indicates the substance is alkaline. To determine the acidity or alkalinity of a substance, we use the pH scale. To better understand how a substance is measured, we must understand how the scale works. The pH scale is based on a logarithm. The term logarithm means multiples of 10. Since the pH scale is a logarithmic scale, a change of one whole number represents a tenfold change in pH. In other words, a whole number change, from 1 to 2, could better be represented in terms of decimals. In the example of a change from 1.0 to 1.1, represents a one-fold change, 1.0 to 1.2, represents a two-fold change, 1.0 to 1.3, represents a three-fold change, and so on, up to 1.9, which would represent a 10-fold change. This also means that a change in whole numbers from 1 to 3 is not a 20-fold change, but rather a 100-fold change. Remember, logarithm means multiples of 10, not additions of 10. Therefore, a change from 1 to 2 would be a 10-fold change, and then a change from 2 to 3 would also be a 10-fold change. 10 multiplied by 10 is 100. So a change in pH from 1 to 5 on the pH scale would equal a 100,000-fold change. Even a small change on the pH scale represents a large change in the pH of a substance. pH is always a balance of both acidity and alkalinity. Pure water has a pH of 7, which is an equal balance of acid and alkaline. Although a pH of 7 is neutral on the pH scale, the pH of the hair, skin, and nails are measured at 5.5, therefore the pH of water is 1.5 times more alkaline than that of the hair, skin, and nails. This difference in pH is the reason pure water can cause the hair to swell as much as 20%, and is also the reason that water is so drying to the skin. Take a look at the pH scale listed here. Notice there are a few common substances listed and represented by their pH levels. Baking soda has a pH of 9. Baking soda is 2 steps toward the alkaline side from neutral. Vinegar has a pH of 3. Vinegar is 4 steps toward the acidic side from neutral. Mixing baking soda and vinegar will produce a redox reaction, where the reaction will release oxygen. Mixing baking soda and vinegar will change the pH of the solution from vinegar with a pH of 3 and baking soda with a pH of 9 to a solution with a pH of 6. Baking soda and vinegar neutralize each other. Let's watch.
Hello everyone. So the experiment that you are about to view has to do with the baking soda investigation that we've done in class. In this investigation, we are going to test the pH value of different liquids involved in the baking soda and vinegar reaction. As we've used in class, I will be using these pH indicator strips. Here's the container. These strips are just yellow strips of paper that are coated in a chemical, and the strips change color based on the substance that they are in contact with. And this will actually tell us the pH of this substance. We are going to start by just taking the pH of this beaker here of vinegar, and we will compare the color on the test strip to the colors on the key on the packaging to see what the pH is. I am going to dip my test strip into the liquid, and I see it has turned a pretty vibrant reddish pink color. If I were to compare this color to my key, I would probably say that vinegar has a pH of about a 3. This means that vinegar is a relatively strong acid. Oops. Now I am going to actually prepare a baking soda and water solution. I have a beaker of water. I am going to actually put 2 spoonfuls of baking soda into my water, stir it around, and now I will test the pH of this substance. And my test strip is coming out as a dark yellow, relatively green color. So if I were to now compare this to my packaging, I can see that the pH seems to be close to an 8. So baking soda is a base and vinegar is our acid. This is going to be significant when we observe the following experiment. So I am going to now combine the two and start the chemical reaction between baking soda and vinegar. All right, so my reaction has occurred between the two, and I am now going to test the pH of the liquid that was produced as a result of this chemical reaction. I'll get my final indicator strip, dip it in. You may not be able to tell, but this is a very bright yellow color, not green, not similar at all to the baking soda's pH. If you look here, you can see the difference between my other test strips. And in reality, this is because my pH is now close to a 7. This means that my reaction between the baking soda and vinegar has produced a neutral substance. So we call this process neutralization, in which an acid and a base come together, and when they react, they produce a neutral substance.
Note: there are many varieties of pH test kits. Test strips, chemical sets, and pH meters are the most common test kits available. The pH test strips used in the video only measure the pH on a whole number scale, which means it will only measure in whole numbers such as 1, 2, and 3. pH meters will measure on the 100th scale, or numbers represented in terms such as 1.25, 1.26, and 1.27. Therefore, the true measurement of the solution is generally measured at 6.7 or 6.8, which would round up to a whole number pH of 7. In quick review, pH measures the quantity of hydrogen ions and measures the acidity or alkalinity of a substance. The pH scale ranges from 0 to 14. 7 on the pH scale is neutral. 0 to 6.9 on the pH scale is acidic. 7.1 to 14 on the pH scale is alkaline. Hair, skin, and nails have a pH of 4.5 to 5.5. Chemicals raise the hair's pH to alkaline levels in order to soften and swell the hair shaft, to open the cuticle layer, and allow the solution to penetrate the cortex. Coarse hair, with a strong cuticle layer, requires a higher alkalinity. Porous, damaged hair, with a weak cuticle, requires a very low alkalinity. All acids owe their chemical reactivity to the hydrogen ion. Acids have a pH below 7. Alpha-hydroxy acids are acids derived from fruits such as apples, oranges, and lemons. Alpha-hydroxy acids are used in salons to exfoliate the skin and to aid in adjusting the pH of lotions, conditioners, and creams. Acids contract and close the hair's cuticle layer. One such acid commonly used in the salon is diglycolic acid, or the acid used in permanent waving solutions. All alkalis owe their chemical reactivity to the hydroxide ion. Alkalis have a pH above 7. Alkalis are compounds that react with acids to create salts. They generally feel slippery and soapy on the skin. Alkalis will soften and swell the hair, skin, and nails. One such alkali product used in the salon is sodium hydroxide. Notice the term hydroxide in the name. This tells us immediately that it consists of hydroxide ions, and we know that all hydroxides are alkaline. Sodium hydroxide is more commonly referred to as Li, which is short for alkali. Sodium hydroxide has many uses in the salon as well as other places. It can be found in hair relaxers, hair depilatories, callus softeners, and drain cleaners. When acids and alkalis are mixed together in equal proportion, they neutralize each other. Some examples of this neutralization reaction can be found in combining baking soda and vinegar, shampoos and conditioners, and even permanent waving lotion and neutralizer. For a product to have a pH, it must contain water. Oils, waxes, and nail polish will not have a pH because they do not contain water. Now it's time for you to test the pH of some of the most common chemicals used in the salon. What is the pH of shampoo? Conditioner. Hairspray. Gel. Mousse. Lotions. Permanent waves. Chemical relaxers. Or hair color?